Hi and welcome. This time around I have a relatively quick project. So when you're trying to square up the edges of a piece of plate like this, or even much bigger than this on the mill, which is what I often do, the problem becomes, how do you set this guy up on the mill so that if you have a square reference edge, or you finally cut a square reference edge, like let's say it's all sides are wrong, so you cut one, make that your reference edge, rotate it say 90, how do you align that so that your next edge will be 90 degrees to that? So if it's not a big deal, I'll trust the saw cut from my vendor some of the time. I usually check it with a square, but it's off and off. So what I end up doing is putting the plate, if I only have one plate to do, I'll put it down on the mill on some blocks, and I'll use a dial indicator to roughly get one side in, run the mill across it, get it square, rotate 90, run the indicator across it to get it lined up again, clamp it down, and then do the other side. It's very, very time consuming. If I've got more than one to do, I'll set up a fence on there, but I don't actually have any good parallels to do a fence. They've all been really mediocre at the job that I need done, which is basically having a flat surface that you can clamp to the T-slots and then have clamps come over the top of the part and then clamp that down as well. It's never worked out very well at all. I've been able to do it with some of my squares, like this one here. This one's very pretty, but not super functional. So this guy right here is very pretty, but these holes only go through on two sides, not all the way through. Which makes it useful for other things, but not for setting this up, because you want to put a bolt straight through to the T-slot nuts, to the T-nuts, to hold this guy down, and then have another clamp come over the top to hold the parts down. Getting all that logistically done is a total pain. I have these other ones that are machinist made that I got off eBay, and I like them a lot, except turns out that the two slots they put for hold downs, they don't line up with any of my T-slots. They're for a much bigger mill. Something with a, I don't know, 12-inch table, maybe 14-inch table, certainly not what I've got. So this doesn't work great either. Ultimately, you get the drift. So I bought some cast iron here. This is 1.5 by 2-inch bar. And I'm gonna make a fence that will have 3 holes that will bolt down straight through to the T-slots on the mill. They will also have additional screw holes on top that I could mount, you know, the 1/2-inch clamp, part of the clamp hold down, so that I could just clamp directly to it. So I could get it all done at one time, because if I had the bolts go through this and held everything down at once, I'd have to constantly realign this. So this piece of material is going to have 3 through holes, 1 for each T-slot, and they're all going to line up, which interestingly enough, my mill, they're not symmetrical at all. That's probably the Chinese manufactured part of it. When you buy Durabar, just know that there's a rather substantial radius that comes on the Durabar, and that's really unfortunate. So this is like maybe 1/4 inch or even 3/8 radius, maybe more. I don't know, it's pretty big, which means I'm gonna have to, in order to get square edges, I'm gonna have to remove a lot of material off this. So make sure you buy a much bigger piece than you actually need, and you're just gonna have to waste a bunch. That's also unfortunate if you want square edges, which I do want square edges here and here, because that is where chips and stuff can get underneath, and I don't think I want that. So if you're wondering where I'm headed with this, here's sort of the idea. I did a mock-up. This would be the mill column side, because the spacing here and the spacing here is off by like 50 or 100 thousandths, maybe more. It's off by a lot. I forget what the measurements are. You can't see it there, so maybe it's like 50 or 100 thousandths, but it's not symmetrical. And the widths of these, they're all supposed to be 0.625. They're all over the place. 0.629, 0.625, 0.632 kind of thing. Clearly, they did not spend a lot of time on making this mill table a precision thing. This is the first, my mill is an Acra mill, but it's a Chinese-made Acra mill. It's the first one they had made in China, and it's about 1/3 the price of their Taiwanese-made mill, and now you know why. They do tend to be straight and parallel, so that's good. Just the space, they weren't careful about the spacing at all. So this is sort of what I'm gonna do. So the 1/2-inch bolts that hold this thing down are gonna go through here, and that'll connect to the T-slots. And I'm gonna add additional threaded holes like around here, 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 and here, where you can mount clamps to hold the part down. And I haven't decided whether I want it oriented like this for taller plate or like this for shallower plate. First step, as always, is the squaring of the stock. Got the face mill in place, and we're just going to take a pass across here and try and clean this up. You notice how big this corner radius is? I don't think I want to remove enough material to completely remove that corner radius, because I will significantly reduce the dimensions of this stock. When I bought it, I had no idea the corner radius would be so high, so I wasn't really compensating for it, or I would have gotten something thicker. I think it'll work fine as is, and the radius is there. It's not going to be an actual problem, so I think we'll leave it to some degree. Let's just see what it takes to clean this up. Final side, final pass, roughing pass. After this, I'm going to head over to the surface grinder and try and make it even flatter and square. Wait, I thought I was done. Why am I doing this again? Because there was 15 thousandths taper across there. Why? Because when I trammed my head, I trammed it exactly 100 thousandths out. I did not notice that I was off by an even 100 thousandths. So it looked like the tramming indicator was exactly 0 and 0. I just didn't notice the 100 thousandths. So I'm back cutting everything again, which means I'm going to end up with square faces, all because I screwed up. I guess that'll be fine. This is the rough finishing from here to surface grinding. The way I discovered it is I went over to my surface plate and I started measuring, and it was off by 15 thousandths side to side, and I couldn't figure out why. And I swapped cutters, which was silly. I did all kinds of things except for check the tramming of the head, which was last, obviously. And sure enough, tram your head. It was knotted forward, 100 thousandths deeper on this side. So it's digging in obviously more here with the cutter, and then you move it back, it cuts in over here. What a mess. And the mill really doesn't like it when it's at an angle like that. Now, you can see the line where they interface, but instead of being able to feel like 10 thousandths or 15 thousandths gap, now it's nice and smooth. What do you know? All right, so I've roughed this guy out, and I popped it here on the surface plate just to measure, and still about 5 thousandths between one side and the other, although where the cutter made 2 passes, you can't even feel that anymore. So I got it within a few tenths, I think. However, it wasn't being held perfectly in the vise. This top part's pretty good. The maximum is about a 1 1/4 thousandths out of square, so that's not terrible. But what I'm going to do is I'm going to stick this on the surface grinder with this side down, and I'm going to get, the reason I went to all this trouble to characterize this, which I should do every time I use a surface grinder, is I know where to pick up on the high spot, because if you pick up on the low spot and you touch off and then you move the high spot, all of a sudden you're taking these big bites that you're not expecting. So it's a good idea to have have some idea where the high spot is. So in this case, the high spot's right here, and I can just work back until I finally clean up down here, and then I can flip it over, do the other side, and then hold this in a vise, or a pair of vices, I guess, and use the fact that these are parallel and do this top part next. And I don't really need to surface grind the top part, but I'm going to anyway, just because it'll look nicer. And then in one of these sides, we're going to cut this profile into it, so we're basically going to make this. We got to remove all that kind of material like that. By the way, I don't know if you can see it, but I reground my fence on this guy. Oh, this is my new fence that I made. That's right, out of steel, and it's been reground so that it's nice and parallel with the direction of motion. I have flipped the block around here and put the high spot in back, because I find it easier to, work towards myself. That way I can see everything I need left to go. So that's where we're headed. All right, I ground both sides by about 1/10 relative to each other, which is really good. And I have 2 grinding vices here that are inexpensive, Asian makes. However, they're about 1,000th off of each other. So I'm going to grind them first to make sure they're both exactly equal to each other, at least height-wise. So when I hold this, I want to clamp this part here. And I guess it doesn't matter so much, but I need to trust these vices. So they're relatively flat. So when I scroll across, they're like within 1/10. But the height between this vise and this vise is about 1,000th difference. So I need to fix that. I should have recorded which one was higher, because Now I've got to figure out which one the high spot is. So we'll scroll across and just touch off. All right, so now that I've ground the bases of these vices to be within roughly 1/10 of each other, now I've got this sitting flat, but that won't matter because these jaws should push flat up against the back. Hopefully those are, in line with each other. I think they should be. Here we have our ground part. Just moving it in and out of the jaws is scratching it. This is not particularly hard material, this cast iron. I think you can heat treat it, but I'm not sure what that is. I might have to look that up, but too late now, but for future projects, might be interested in that. All right, so off camera, I popped 3 holes in here, 1/2-inch clearance holes for the slots, the keys that are going to go in the slots on the mill. On my mill, the spacing, they're not equal, unfortunately. I did 2 plots, one with 3/4-inch roughing end mill and another one with 1/2-inch end mills. And the reason I did these so I could figure out how far off center I need to go to clear out material. And what you'll notice is this one 1.783, this one 1.752. That's 41 thousandths difference. I don't know why they weren't that careful, but maybe it's because, well, it's an inexpensive casting. They did grind them, and I have checked with an indicator, and they're parallel to the motion fairly accurately within a few tenths. They just didn't space them equally, and I don't know if that's normal or what, but in any case, look, 1.814, 1.845, 1.761 to the edge, 1.773 to the edge. I don't know. But anyways, I did do 2 slots. I'm going to start with a roughing end mill and 3/4. I like to use larger diameter end mills for roughing because they're stiffer. And then switch over to a 1/2-inch end mill for cleanup. And that's when we'll try and get these keys pretty close to the milling slot diameters. Now, one thing I would like to point out is I'm not going to make them so that they are a super precision fit, because it turns out that you'll probably have to indicate them in anyways. So I want to make them really close, so I only have to tap them a little bit to get them right on the money. It'll be close enough that you can do, fairly, mild accuracy work. I know as machinists, we're all looking for super precision. Sometimes it's just not necessary, and pursuing it is a waste of time relative to your income. For me, it's a hobby, so I can spend as much time or as little as I want. So I don't have the same constraints, but I still try for it because it's always harder to be precise than not. So I just do that as a matter of practice. One thing is I have learned my lesson, and when you're taking big bites with a milling cutter, if you use a standard collet, that the tools tend to pull out. So I'm going to find a tool, the Weldon flat, and I'm going to use one of these holders, and hopefully we won't have that problem. Something I want to point out is that this is a couple days after I did the initial machining on this, and I wanted to point out that the way I left this was I locked my X and Y axes with the locks. I turned off my DRO, and I had it set at 0 before I locked them off. So I got my X and Y axes set at 0, 0, and then I locked everything off. And then I turned it off. So the thing you got to make sure is when you turn it back on, you turn your DRO on first, and then you can unlock your axes and move them. Because if you do it differently, you can get caught like I did once before, many years ago, and you think everything is still correct, but it thinks you're where you left it, when in fact, it's not. And the DRO will be wrong, and you'll have to refine your centers. If you're really doing precision work, you should always find precision centers anyways, because things could have cooled off or heated up since the last time you used it, and they could be wrong. The roughing end mill I'll be using is this 3/4-inch corncob type. This is, I think, carbide. I am not 100% certain of that. We'll be running a fairly low RPM. Let's see, does it say? Nope, high-speed steel. It's a Hertel, and it is high-speed steel. And the beauty is it's got a Weldon flat on it, so that set screw can go in there, which limits its up-down motion significantly. All right, so we're going to try and slog through this at low RPM, relatively speaking. Right now we're going to start at 200 RPM, and we're going to go with depth of cut 0.473, roughly 0.475, and we'll do the last 25 thousandths with a 1/2-inch end mill. I'm not going to take a full bite the first bit. I'm just going to try and see how it goes. Contact. I think I'm coming in contact with about 3/4 of the end mill diameter. 3/4 of 3/4. There you go. Seems to go pretty smoothly. The reason I'm using the 1/2-inch finishing instead of the roughing is because of what you can see there, those lines from the corn cob. Roughing end mills don't leave a good side finish. They do a pretty decent job on the floor finish, as you can see there. And that would be more than adequate, but we're going to take the 1/2 inch finishing end mill and see if we can improve on that. You will notice how thin these walls are even with extra material on them, and that's because the 1/2 inch hole is the clearance hole for 1/2 inch bolt is a 1/2 inch, and the slots are only 0.629 wide, which gives me a 1/16 of an inch, or what is that, 62 thousandths roughly per side. So when I'm done with the 1/2 inch end mill, these are going to be really thin. Here we finished the roughing for the part. Now we're going to do the finishing with the 1/2 inch end mill. Here is a Weldon flat 1/2 inch end mill, and so we're going to put it in a similar kind of holder, because I've had a lot of problem with 1/2 inch end mills sucking into the work as they cut. You think they'd be pushed away, but they almost always get sucked in, and you end up with starting at the right depth and deeper by the time you're done, which always sucks. Oh, look at that. I don't know if you can see that. I'm like a couple tenths over. Not bad at all, considering. The problem I find with using this kind of tool for measuring depth is that this screw has so much leverage that it's very easy to lever the part up as you're trying to find the bottom, and that can be really challenging. I've made that mistake before where you tighten it and it levers it up and you can't feel. So now I push really hard on one side, and when it just starts to feel snug, I stop. And I can get, I guess, within a couple tenths using that method. All right, so here we are done. And what I'd like to do is test it. I've got to deburr these edges, although cast iron's so powdery, it does turn a burr occasionally. Not very much of one though. These cuts are all pretty darn clean. So that I can put this thing back in the mill if I need to remove some material inaccurately, what I really need to do is find a reference point. Unfortunately, I didn't set this up. You know, I could have set this up with a stop so I could fit a parallel in here, but I didn't do that. I could find a gauge block that fit in there, and that would probably be good enough to get me within a few, a thousandth or two, which is all I really need. So being very careful to put this in very gently. I found a pair of gauge blocks. It's exactly 2.225, which is really interesting, and that slides right in there. So I can take this out and put it back. So here's my gauge block stack if I need to put this back. And let's pull this out and see if it fits. Well, there's a crazy precise fit. This thing starts in every single slot, but it's just barely too tight. So I'm going to take like 1/1000th off of each side, which will take 2/1000ths off the total diameter. It'll probably make it slide in, but that's what I want anyway. This is way too close. All right, so I was able to get this guy lined right back up again. Column side still to my left, which is important. I should be within a fraction of 1/1000th, hopefully, if I did everything right. Got this thing tightened in. Let's take some material off. Here comes the 1/1000th off of this side. Okay, before I remove this, I got a new gauge block stack. Went up 2/1000ths. I was trying to go up 1.5 It's a little bit tighter. So I think we're right on the money, hopefully. This does have Belleville washers in it, so it can move a little bit, a few thousandths. So I got to be careful about that. Let's see how the fit is now. All right, so the fit is still pretty snug. There's no adjustment range here. And if there's any variation, the T-slots, it's going to be really challenging to get this in. It is a really good fit. I mean, I couldn't ask for a better fit than that. I'm tempted to open it up just a little bit more so that I wouldn't have any problem. As I move it, yeah, it's getting tight here, see? Because I don't think the T-slots are perfectly ground. I think they're close. So I think we need to open it up just a little bit more. And then it'll be a little sloppy in some spots and tight in others because my mill's not perfect. And I'm going to probably want to indicate it in anyways. So we're going to look to take another 1,000th off. I changed my gauge block stack again. And I wrote down the numbers that I was using to mill this off. I also got off by a whole digit over here. As you can see, I started and just, you know, I can't seem to do a project without screwing something up, right? It's like some witness mark to the fact that you're just not there yet as a professional, because if I was going to sell this, I'd have to scrap this part. So because of differences in the milling slot here, even though it's been ground, I took another 2,000ths off each side, which is 4,000ths, which is quite a bit really, but that's going to ensure there's plenty of room for any spot on here. And if I need to be super accurate, I can tighten one side and dial in the other. Next step, we need to take this, flip it over. I want to countersink this, and I also need to drill and tap 4 spots to hold down clamps. So the hold down clamps, will use this as a mount instead of the T-slots, and that means I'll need some short studs, some short 1/2-inch studs, which I'll make as well. Let's get by countersinking this. I got to find the center again, and we should be good to go. So I don't know if you can see this, but I've got my stop here underneath, and the same gauge block stack, when it was flipped over, it should theoretically be very close. I think it was within 1,000. So now I'm going to use my center finder and see how close I was using the same gauge block stack underneath this time instead of on top. The gauge block technique worked better than I thought. We're with less than 1,000. Next up, I want to countersink all the holes on top. I have the countersinking bit in a collet. That makes it lower profile. Okay, 520 thousandths. Perfect. That's 10 thousandths below the top, which is perfectly fine. Instead of 0. So 5 thousandths, 10 thousandths. That'll work. So next up, we need to drill the 4 holes here. And the drill bits I'm going to use are these Drill America cobalt bits that they sent me in this really cool case. If you have a tool kit and you want to carry your drill bits, this is a lot more convenient than a standard Huat index, because the Huat indexes always end up opening up a little bit, the drill bits scrambling all over the place. This keeps the drill bits not only together, but also dry. Oh, look at these interesting drill bits. Besides having a center drill tip, these Drill America drill bits also have sort of a chamfering finish on the end, except it's not smooth, it's stepped. So they basically got a center drill, a step drill, and then the actual final drill size. Very interesting. On top of that, they have a three ground flats in it. So if you're using your drill motor, you're not going to get spinning in the chuck because the jaws will grab on the flats. Another nice touch. First drill hole, this is going to go all the way through. So it doesn't wander, the drill bit doesn't wander much at all, which is fantastic. Cuts like butter. The inside of this Durabar is a different hardness than the outside. Very noticeable when you're drilling. The inside actually appears to be harder. Oh, that went through like butter. So we're going to go 1 1/4 inches deep. Could have used my tapping head, but it's only 4 holes. One thing to notice with these guys is that a normal drill bit the cutting edge, the full diameter cutting edge, is maybe like 20 to 100 thousandths, you know, under the tip, the point where the point's cutting. On these guys, because they've got a step drill and a center drill, you got to make sure you got big enough parallels in there. You don't actually drill into your vise or your table. So just keep that in mind when you're using this, that it's got the step drill action, which is really useful, along with the center drill action, very useful as well. Make sure that you don't forget and drill into your vise. I was all ready to test this guy out until I realized I fooped. Look at that. See that? I need to take that 1/2 inch down there does not allow the T-nut to come up high enough. I didn't even think about that. I thought it was deeper than that because it's 1.1 inches. So I thought, oh, see, the T-nut's probably close to 1/2 inch thick. So right there, I need to remove 1/4 inch of material off this part sticking down here because it's way too much and it's causing the T-nut to not be able to tighten up all the way. Nice. Well, sometimes you screw up and sometimes you screw up. Got to tell you, it's kind of killing me. We're going to take this ground surface right off of here. Going to take 1/4 inch off of each one, a little bit more actually. All right, so here's the project completed, and it worked out really well. I surface ground all the sides, including the bottom, which I didn't need to, and you can see where I took too big a bite there and it heated the material and discolored it, but I did, you can't feel it, so it's all nice and level within a couple tenths. You don't need to surface grind the bottom. I recommend surface grinding the sides that are going to be your perpendicular sides, although it's not absolutely necessary, depends on what kind of precision you're looking for. Countersinking these holes is really useful because that makes the clamps be able to fit, you know, across where the screw sits if necessary. So that's a nice feature. I made 3 of the studs, even though I'll probably never use more than 2 clamps because my milling table is not wide enough to really fit that. And all in all, I think this is an extremely useful project. It's one I'm going to use all the time because I do a lot of squaring of tooling plate. I don't know about the rest of you, but anything that doesn't fit in the vise that you need to square, this will be handy for. I made them the keys sloppy enough that when I tighten this side down and you get your indicator here, you don't want your indicator here because then you're going to go one direction and then the other direction. So you start with your indicator here at the rotation point, tighten this guy down and loosely tighten these two and wiggle this back and forth. The far end here has like 10 to 15 thousandths of play, which means I can dial this in right on the money, which is really handy, so I can get as square as I need to. All right, so here's my basic setup. I've got all 3 T-nuts engaged because if I'm going to be levering off this guy, then I need some support there. And then I've got studs in 2 of the locations right now. And this is the top, the column side. This is the side closest to the operator or me. And these are the 1-inch tooling plate spacer blocks, and you can see I've hit them with screws with drill bits before. It's because I'm not overly concerned they're sacrificial. I do take a precision ground flat stone and run over these before I use them each time, just to make sure they're level and flat. And I look at my material here, and there is the saw cut side. So I'll put the saw cut side up. I indicated this guy in, it's within 1/10 or 2. And then I can let the end stand just proud. And I can pop a clamp on each one of these guys, as you can see back here. If the stair steps are not tall enough, I whip out a 1, 2, 3 block, and that pops them. Or if they're, you know, across a T-slot, then that helps them bridge it. And pop it on there, and then tighten these nuts down, and I've got room for 2. So you can see how that's going to work out. So now I'd mill this side right here because it's perpendicular to this side over here. Then I would rotate that 90. Do the next side, rotate, then I could flip 180 potentially or rotate 90. You could do it the same way you set up things in the mill. Right now I left my mill vise on here, but when I'm doing this, I normally have this towards the center. I just left my mill vise in place because I'm just demoing what I do with this. So as you can see, you can do fairly large plates. This fence is extremely handy to have. So probably something you want in your shop. I think it's one of the most useful things I've done, especially if you use a lot of tooling plate that you need to square up, which I do. I do a ton of it. I think the design is great. If you're going to do thinner plate than this is 1-inch plate on 1-inch spacers, but if you're doing really thin plate like 1/4-inch plate, then maybe you do want to do this on the side or make 2 of these, one on its side so that it doesn't stick up as high. I mean, it still works, but you could run into this and you may need to put spacers on top of your plate, but that's not the end of the world. So just some thoughts thrown out there. Hope you find it useful. Hope to see you next time. Thanks for watching.